Hi there, in this video I'm going to talk about the predictive analytics, which is the third type of analytics. If you remember from the previous two videos that we discussed descriptive and diagnostics, which are mainly focused on current data, but predictive and prescriptive are talking about future data. One will generate the model, which is predictive. The other one will recommend the model, which is prescriptive. And here for the predictive, we are going to talk about two different types of analytics. The first is regression, and the second one is classification. What do we mean by regression? If you look at this graph, you will see the volume on one axis and the other one the days to ship. And here we put one of those variables as independent and the other one is dependent. So here we say the days of shipment depends on the volume to ship. So here the independent variable is volume and the dependent is the day to ship. And then we make a line between them to show what is the future that might happen if the volume increases, how many days will it take to ship this volume. And from here we say the regression estimates or predicts the numerical value of a dependent variable, which is days to ship in our example, on the slope and the intersect of the line, which you can see it here, the diagonal line, and the value of the independent variable, which is the volume. So how do we do that? First of all, we need to identify the variable that might predict an outcome. So we need to know, is it volume? Is it price? Is it distance? So we need to identify the variable. Then we determine the functional form of the relationship. Is it linear or non-linear? And number three, we need to identify the parameter of the model. And then we come up with the model. Well, the model is the dependent variable, which is the days to ship, is a function of volume, which is the independent, and we can put other independent variable to come up with a model. So this is the meaning of regression, to predict what's going on. Good example here in managerial accounting, regression may be used to know the employee turnover. The employee turnover is the dependent variable, which is a function of the salary, the health of the economy, the salary offered by other company, and so on. If we put all this independent variable, we can predict the employee turnover for the future. Another example in auditing, we might do regression to determine the appropriateness of allowance accounts. And the allowance for loan losses is the function of the aged loan, the loan type, the customer loan history, the collection success. So the allowance here is the dependent variable. And the age of the loan, the type, the customer history, and so on are independent variables. The second type is the classification. What do we mean by classification? Here we predict a group or a class or category for a new observation based on the manual identification. So here we make 6 steps to do the classification. First, we need to identify the classes or the categories we wish to predict. Then we need to classify the existing set of record into those classes. Then we select a set of the classification models, divide the data into training and testing, and I'm going to explain the training and the testing data. Then we generate the model, and then we interpret the result and try to take the best model. And here is the point, which kind of model we need to get it. So here you have 3 models. The first one on the left, where you can see we put circles and squares, and we would like to imagine the relationship between the circle and the squares by drawing a line. If you draw a line, you will see that lots of circles are on the bottom and lots of squares are on the top. So we say this is underfitting model. But if you look at the second one in the middle, you see that it takes mainly all the circles and few squares. So we say this is good model. If you try to make it really, really perfect, which we call it overfitting, this is not the best choice. So here, if I go for step 6, interpret the result and select the best model. The best model here is the good one, not the overfitting. So please try to avoid the overfitting model when you do classification, because they look really bad in predicting the future. But we need to look for the sweet spot where we can maximize the accuracy of the training and the testing data. So here in the oval area of the sweet spot, we say this is the best area that can help me to make the classification. What do we mean by training data or testing data? Training data, we give some data to the machine, like machine learning. A good example, Azure, it's one of the machine learning where you feed the system with some information and you train the system to predict the future. We call it training data, the existing data that have been manually evaluated and assigned to the class. The second thing, we test the data, are existing data used to evaluate the model. And then we have decision tree, as you can see it here. If we have a new client, shall we accept or reject? So here we split the decision into 2 types. And then if we accept, what shall we do? Check his credit history or we don't check? So here we try to make 3 of decisions to divide the data into smaller groups. And then we make boundaries for the decision, mark the split between one class and another. And here, if we end up by having too many legs in the decision tree, then we can do some pruning. So the pruning removes the branches from the decision tree to avoid overfitting the model. We try to go for the best one, but not for overfitting the model. The next one is the linear classification. Linear classifiers are useful for ranking the items rather than predicting the class probability. So here we try to rank them. These are useful for determining the really important values, such as valuable customer, which transactions are most likely fraudulent. So the last one is the support vector machine. The support vector machine here, where we can have an area in the middle. It's a discriminating classifier that is defined by separating hyperplane that works first to find the widest margin or the biggest pipe, and then the middle line between them. And as you can see here, for the last one, we try to measure the relation between the distance and the volume, and we try to see the area here between the dotted lines and the one straight line in the middle. If we come up with a decision within this area, it's okay. If it's outside, it will show us an error. So this is what we mean by support vector machine. And I hope you find this short video about regression and the classification useful about predictive analysis. Thank you.